Chapter 2, Section 2, Physics Talk, Seat Belts and Newton's First Law of Motion. The three parts of Newton's first law. Newton's first law of motion, also called the law of inertia, is one of the foundations of physics. You probably have already encountered Newton's first law. It states, an object at rest stays at rest, and an object in motion stays in motion in a straight line with constant speed unless acted upon by a net external force. There are three distinct parts to Newton's first law. Part 1 says that objects at rest stay at rest. This hardly seems surprising. Part 2 says that objects in motion stay in motion in a straight line with constant speed. This may seem strange indeed. After looking at the collisions in this section, this should seem clearer. The automobile and the clay passenger were moving at constant speed. Even though the automobile stopped, the clay passenger continued moving at the same time, at the same constant speed until it hit the barrier. Part 3 says that parts 1 and 2 are only true when the net force, or total of all forces, on the object is zero. An object may have forces acting on it and still have no change in its motion. For example, a book at rest on an outstretched arm has two forces acting on it: gravity pulling the book down and the force of the arm on the book pushing it up. Because these two forces on the book are equal and opposite in direction, the forces are balanced. They cancel each other out. Let me read that again. Because these two forces on the book are equal and opposite in direction, the forces are balanced. They cancel each other out. The net force is zero, and the book remains at rest. In your simulated automobile accident, the cart stopped and the clay figure kept moving until it hit the wall. This action can be explained using Newton's first law. An object at rest stays at rest. An object in motion stays in motion unless acted upon by an unbalanced force. The cart and the clay figure were moving at a constant speed. The wall stopped the cart, but the clay figure continued moving at constant speed until the wall stopped the clay figure. Human beings have much more complicated anatomies than clay figures. This leads to more complicated actions during a collision. 3 collisions in one accident. Arthur C. Damask analyzes automobile accidents for insurance companies and police reports. This is how Professor Damask describes an accident. Consider the occupants of a conveyance moving at some speed. If the conveyance strikes an object, it will rapidly decelerate to some lower speed or stop entirely. This is called the first collision, but the occupants have been moving at the same speed and will continue to do so until they are stopped by striking the interior parts of the automobile, if not ejected. This is the second collision. The brain and body organs have also been moving at the same speed and will continue to do so until they are stopped by colliding with the shell of the body. For example, the interior of the skull, the thoracic cavity, and the abdominal wall. This is called the third collision. Newton's first law of motion can explain these 3 collisions when an automobile strikes a pole. The first collision. The automobile strikes the pole. The pole exerts the force that brings the automobile to rest. Second collision. When the automobile stops, the body keeps moving. The structure of the automobile exerts the force that brings the body to rest. Third collision. The body stops, but the heart, the brain, and other organs keep moving. The body wall exerts the force that brings the organs to rest. Even with all the safety features in automobiles, some deaths due to accidents cannot be prevented. In one recorded accident, only a single automobile was involved, with only the driver inside. The automobile failed to follow the road around a turn, and it struck a telephone pole. The seat belt and the airbag prevented any serious injuries apart from a few bruises, but the driver died. An autopsy showed that the driver's aorta, large blood vessel, had burst. At the point where it leaves the heart, the man An autopsy showed that the driver's aorta, a large blood vessel, had burst at the point where it leaves the heart. The man's organs were damaged during the third collision when the heart collided with the skeleton. Force per unit area. Designing a safer seatbelt. In Part B of the Investigate, you used a seatbelt to stop the clay passenger. Newton's first law states that an object at rest will remain at rest and an object in motion will remain in motion unless acted upon by an unbalanced force. The cart stopped, but the passenger continued to move forward until a force acted upon it. In this part, the force stopping the passenger was the force exerted by the seatbelt. Some of the seatbelts you used did not work as well as others. Each time you repeated the investigation, the stopping force that the belt exerted on the clay was the same. The force was the same because you released the cart from the same height each time, yet different materials had different effects on the clay passenger. For example, the wire cut far more deeply into the clay than a broader material did. The stopping force that each of the seat belts exerted on the clay was approximately the same. When a thin wire was used, all the force was concentrated onto a small area. By replacing the wire with a broader strip of material, you spread the force out over a much larger area of contact. Force that is spread out over a given area is called pressure. Pressure is defined as a force per unit area. The pressure is much smaller with a ribbon, for example, than a wire. It is the pressure, not the force, that determines how much damage the seatbelt does to the body. A force applied to a single rib might be enough to break a rib. If the same force is spread out across many ribs, the force on each rib can become too small to do any damage. When the total force does not change, the pressure on each rib becomes smaller.